Before we go back to fuel injection systems, I've discovered that we have a problem. And by we, I mean you, which then became my problem. So we need to go back a week and talk about pressure pumps. And what I think the problem is that you focused a little too much in on the diaphragm pump and sort of left this constant displacement pump behind. And so first thing you need to realize is there is a significant difference between how the diaphragm pump works and how a constant displacement pump works. And there are certain things that I kind of thought were maybe a little more intuitive than they are, but that's okay. So we go back to a constant displacement pump, and you might want to take some notes. I may not write many for you, but why is it called a constant displacement pump?
It will always be outputting constantly fluid.
Oh, okay, always puts out fluid. I like that.
Constantly displaced in the same amount consistently.
Same amount consistently,
For the input
yes,
speed.
but what?
For the input speed.
For the speed.
For RPM.
Okay, so if I turn this pump right here at 1 revolution per minute, it's going to put out a certain volume because every one of these little chambers has a certain volume. But if I turn it twice as fast, what's the volume going to be? Twice as much. Okay, so that'll be 2 revolutions per minute if you're trying to keep track of that. So it's constant displacement, meaning that constant per revolution. So the higher the revolutions go, the more it's going to put out. All right, so we got that going. Now, the thing about the pump that you're going to be working with, and that we have the pump inlet, it goes through the pump, you have the ability to adjust the output pressure. And that is done by this screw up here. Well, there's more to it on the actual ones. There's an actual screw up here. This is a locking nut. But anyway, you have the ability to adjust this spring. And by putting more pressure on the spring, it's going to push down this little plate. It means more pressure from the pump. It takes more pressure from the pump to push this up. And if I back off on the spring, that means that less pressure will go this way. So if I barely put any pressure on the spring and I start the pump up, it's going to go the path of least resistance. And if it's easier for it to go up through this little bypass, it will. So if I take the pump and I hook it up to something, and we'll say a fixed orifice, and right here I put a pressure gauge, and over here I put a little wheel that's attached to a flow gauge. So I can monitor pressure and flow. Everybody got it? Okay, I'm on the pressure side of the orifice. The orifice is a little bit different. Whatever happens on this side of the orifice is going to depend on what's going on later. So we don't really know about that right now. But I set this right here, and I set it for this orifice at a certain RPM. Let's say I set it for 1,000 RPM. So when the pump is moving at 1,000 RPM, it puts out 20 psi. We'll say 20 psi, and I'll say a flow of, whatever, 10 gallons per minute. All right, so there's the pump. It's going along at 1,000 RPMs. This says what?
20.
I'm hoping everybody's listening here. 20?
Well, I can't really see where it's
Oh, thank you for... Here?
20.
All right, so we got 20 psi, and the flow is what?
10 gallons per minute.
Okay, at 1,000 RPM. So now I have to switch pens. Thank you very much. All right, so, and the reason why it's doing that, possibly, is some of the fuel is going this way, and some of it is going up this way, because the pump is probably putting out more volume than we can use. Right? So where does the extra volume go? Let's say the pump is putting out 15 gallons per minute. Where's that extra 5 go? Hey, just 5 gallons per minute is going to come around here. And so we have 5 gallons, and I'm making up these numbers, by the way, okay? So don't write that down and say, well, that's what you said. It's 5 gallons per minute going through there. All right, so I'm making that up. So 5 gallons per minute is going this way, and I've got 10 going this way. pressure's 20, flow is 10 gallons. All right, but then I say, well, you know what? Let's increase this a little bit. Let's go to, again, making up numbers, 1,500 RPM. So I speed the pump up. It's going faster. Is the pump pumping more volume now?
Yes.
Okay, remember, pump pumps volume, not pressure, especially this one, this type of pump. So volume's going to go up. What's it going to go up to? I don't know. It just goes up some. But let's take a look at right here. What is my PSI going to go? I've speeded up the pump. We've all agreed the pump is putting out more volume right here in this area, in this area. Sorry, here. We got to go backwards. All right. So the pump is putting out more volume in this area. So what is my PSI here going to go to?
Increase
25.
21.
30.
25, 30. Okay,
That's the same issue.
what exactly was all of that conversation about this for?
20 psi. And then it
What does this
opens-
do right here?
It's release. If it's 21, it relieves it.
It's a pressure relief. And I've set it for how many PSI?
20.
Okay, so this is where I lose people. It's set for 20 PSI. So how many PSI would I see?
20.
Why am I going to see 20?
Because the rest of it is
Because I set it for 20. That's what this is all about over here. So but didn't I also say, or we agreed, that there's more volume in this area right here? What happened to that extra volume? This had to open up more. So that opened up a little bit more. And a little bit more fuel went around this way. How much went this way? Well, we just agreed that the pressure stayed the same. So if the pressure stayed the same, what'd the flow do? Oh my goodness, the flow stayed the same. Why did it stay the same? Because it had a fixed orifice. If it's got a fixed orifice and have a fixed PSI, then the flow is going to stay the same. Everybody follow me so far?
Yes.
Okay.
Did you always have a fixed orifice?
No, you can have variable. Well, are all carburetors fixed orifices? They're variable orifices. But we got to walk before we can run here. All right? All right, now what do
Spring, more loading on it, wouldn't
Yeah,
it?
it should be a little bit more lower.
Okay, so if we want to get super technical now, and I'm trying to get everybody to come up together here. So, okay, will it stay at exactly 20? I mean, will I see that thing just pegged at 20? If I was 20 right here, is it going to be exactly 20? No, it's going to creep up a little bit. Why? Because the more this plate opens, the more it pushes on the spring. The more it pushes on the spring, the more fuel it takes to open it. So maybe it's going to go to 20.2, maybe 20.5, maybe, but you'll see a little bit. But if you see a little bit, then do you then say, if I ask you what happened to pressure, oh, it went up. Is that the correct answer? No. Then it went up means, man, that thing's going to peg. It's going to go 25, 30, 50, 100. I don't know. I'm like, well, it went to 20.1. Well, I said it would go up? No, okay. So, all right. So let's try this again here now. So, pen. All right. So let's go way up. There, thank you. Way up. So I speed it way up. Now what's going to happen? What is the PSI going to do? Probably stay the same. Okay, 20.5. I don't know. What's the flow going to do? Stay the same. Okay, maybe 10.1. I don't know. All right, because that spring is getting compressed, so flow is going to go up a little bit. What?
This is only really if the pump is designed
I'm getting there.
that because even the bypass valve is
I'm
basically
getting
an
there. Just hold on.
orifice.
Just hold on.
Okay.
Just hold on. All right. Now I'm going to go to 10,000 RPM. Okay? What do you suppose is going to happen now? Okay, at some point, this pressure relief valve can't go up anymore.
Right.
And when it's all the way up here, what happens to the PSI?
Goes up.
Okay, now it's going to start going up. So now that's going to go up. I don't know what it's going to go up to. It just depends. So now it's going to go up. Then what's the flow going to do?
Go up.
Okay, now it's also going to go up. Everybody follow. I'm worried that a couple of people are like, yes, and then the rest of the class is going, huh? And so all of the orals so far have been, huh? Okay, so I don't, all right, not all of them, I'm sorry. All right, so we understand that. At some point, this will be up as far as it's going to go, and at that point, the flow has to go somewhere. As much as possible is going this way, but it can only handle so much. That means so much has to go this way. All right? And that means that the pressure here has to go up. And if the pressure up here goes up, then the flow also has to go up. That's just basic fluid dynamics. If you have more pressure going towards an orifice, it's going to push more out. All right? I guess we could use the garden hose analogy. Does anybody put the thumb over the garden hose? All right. And then if you turn up the faucet a little bit more, does more squirt out further? Right? Okay. I never thought of that. All right. Let's go the other way. So we had it all the way up here at 10,000 or 1,000. So now we're going to kind of go back the other way. So from 1,000, let's say I go to 800. All right. What's going to happen right here? Okay, it's going to start closing down. What happens to the PSI? Stays the same. What happens to flow? All right, I better write that down or I'll regret it. So we're back to 20 and 10. All right, now I'm going to bring it down even more. So now let's say I brought it down to 500. And now this time when I bring it down to 500, and again, I'm making up these numbers. Please don't think that when I get 500 RPM that this is what happens. It's just in my scenario. It's a story. It's made up. But the actions are real. All right. So at 500, this thing closed. It just closed all the way. Just kissed the little seat. Just a little peck, like you're kissing your sister. All right. So it just barely, it's riding up there, kind of chattering maybe a little bit. So it's just barely holding it. And so what is my PSI at that point?
20.
Okay. You're right. So 20. And the flow would be? 10. Okay. But now you see we're right there. Now I drop it another 100 RPM. What's going to happen?
PSI is going to go down.
All right. Now my PSI has to start going down. Why is it going down?
Because you don't have any more bypass, so you don't have any more reserve.
Okay. So what happened is, and you are correct, this is now, what's that?
Unless the fuel pump inlet pressure happens to be also from the boost pump supporting
You're
the
just
outlets.
you're just making things worse for someone. I know. Now be careful, okay. So all right. So this is totally closed. So no fuel is bypassing here at the 500 already, and so it's just barely keeping up with the 20 and the 10. And then I drop it down more. Well, how much fuel is going this way?
Zero.
None at all. A minute ago, none was going through there, and then going through here. Now the pump isn't even able to put out as much as it was before, so the pressure's got to drop because the pump just isn't working that hard anymore. It's dropped below its minimum per se, and so now the pressure starts to drop. And so if the pressure drops, what does the flow do? Because it's the pressure across an orifice, it's going to drop. So this is also going to drop. How much? Oh, I don't know. That just all depends. So we have all that going. All right, so let's take it back up to 1,000, and it's back at the 20 and it's the 10, and this time I close off the orifice. I'm just going to lock it down, screw it down, closed, forget it. So we're still at 1,000. What's my PSI going to do?
20.
It's gonna rise.
It's going to go up, right?
Yeah.
No. Well, why won't it go up?
The bypass level is set at 20.
What the heck was this all about?
Don't know.
What does this do? Release pressure. What's it set for? 20. So what is the pressure going to be? 20. That's what it's there for. So what does this do? Well, it just has to open up a little bit more because nothing's going this way. So it just opens a little bit more. Why? Because that's what its job is there for. Set at 20. Is it going to go up a little bit? Sure. 20 point something. I don't know. But yeah, because it had to compress the spring. So that's going to go to 20.
So no matter if you screw it down or up.
I didn't get there yet. I closed it. But the bypass, it just opens up more and lets more fuel go around. So my pressure stayed at 20 because that's its job, to keep it at 20. All right. But what did my flow do? Zero, because nothing's going that way. All right, let's try something else. Okay, so we'll put it back at 1,000. And this time I'm going to, oh, that was nice. I'm going to open this. Ooh, you know what? We're just going to get rid of that. And let's see, pen. And we're going to get rid of the orifice altogether. So the orifice was there. Now it's just really wide orifice. What do you suppose the pressure is going to do now?
Depends on the volume of the cylinder.
It really does depend on the volume of the pump. But given where it was before, given and depending on how high this was, what is the pressure likely to do at this point with a much wider orifice?
Decrease.
Probably drop a lot. So the pressure is going to go way down. Why? Because there's nothing blocking this here. It's free flowing through there. All right? And what's the flow going to do?
Increase.
It's going to go up. Why? Because there's nothing blocking it. So yes, the pressure goes down, the flow goes up. So you can't always say, if the pressure goes up, the flow goes up. You can't always say that. Can't always, make sure I say that right. Pressure went down here, pressure went down, flow went up. So it depends. You can't just throw out blanket statements. You have to stop and think what's happening. Why did the flow go up? Did the flow go up because I increased the pressure of the pump, or did the flow go up because I took away the restriction? If I took away the restriction, then it's going to be an inverse. If I increase the pressure on the pump, then the flow is going to increase, so it's proportional. So it can be inverse or proportional. It depends on what you're doing to make it work. So from your perspective, you always have to back up and look at it. And the easiest way to do this is to remember, what is the job of this?
Keep it steady and even.
To keep the pressure steady and even to the best of its ability. All right? It's got limitations. At some point, it's going to open as much as it can. At some point, it's going to close all the way. Once it closes all the way and you keep slowing the pump down, what happens?
Pressure decreases.
Pressure has to go down. And once it goes all the way up and this right here is smashed up against here and you speed the pump up, the pressure has to increase because this has just done all it can. It's like I've opened as wide as I can. I don't know what else you want from me over here. I'm doing the best that I can. So, all right. Does that help? Yes.
Can we go over when pressure and flow would be directly versus inversely proportional?
All of this. Well, okay. So when will flow and pressure be directly proportional?
When
All
will
right.
it go up or down?
So in order to do that, what I have to do is I've got to come over here and I'm going to make my fixed orifice again and say, all right, so I want all these, the PSI and the flow stayed the same, right? Okay, so how can I make my flow increase? Okay, let's say I have a steady, let me see. I don't know if that's going to work well.
Well, you don't have to erase that.
Well, how do I do it?
You can press the bullet erase all on the slide. Oh, wait,
Well, I didn't want to erase that.
Gotcha.
So I kind of knew what I was doing. For once, right? All right. So in this case, when are they proportional? Well, if I've got it at 1,000 RPM and I want my flow to go up and I want the pressure to go up, PSI, what do I need to do? Well, increase the pressure. How do I increase the pressure? Screw this down, put more spring pressure. What happens to my pressure here? Increase. What happens to flow? Increase. So that's the only way I can do it is to increase the pressure is to do this. Increase pressure here, then the flow is going to go up through this. Did the flow right here change at all when I did that? No, because the pump didn't change RPM. So the flow coming out of the little pump wheel never changed. All I'm doing is diverting how much goes this way and how much goes that way. So if I turn up the pressure here, then the flow through here, because the orifice, is going to increase. If I back off on the pressure, then the pressure is going to go down, the flow is going to go down. That was a good question.
So
Yes.
inverse.
So, if the orifice is blocked off,
Orifice is blocked off.
the fuel that's going through the pump inlet, but
Here.
yeah,
Okay.
would that stop and the fuel that's already in there just keep flowing through?
Yes.
So there'd be no more pump inlet. The
Right.
fuel would just keep.
So if I put a flow meter right there, it'd say 0.
Okay.
And it just come through here, go through the pump, come around, you just sit here and do this.
Okay.
Except I've seen some of the pumps you guys build that leak pretty bad, so there'd be whatever's leaking would come in. Yeah.
So to kind of put it simply, you could say that it's directly varied when the pressure adjustment is changed, and it's indirectly varied when the orifice has changed.
I like that. I like that. So that's something that when you are doing your pump oral, and especially when you get to the stand, I'm going to ask you all kinds of questions about what's going to happen. And the thing that always surprises me is that as I ask somebody a question and they kind of go, yeah, I don't really know. And then I'll actually ask, did you do that? No. Because like one of them, what happens if you increase the speed of the pump? Pressure goes down? I'm like, what happened when you did it? I didn't. Well then, why not? so
But it's still neglecting the bypass valve in a way, though, right?
what's that?
It's what we discussed is still neglecting the bypass valve.
Okay, yes, we've completely neglected the bypass valve. So you want to talk about the bypass valve a little bit? We can talk about the bypass valve a little bit.
Well, I don't know. I mean, technically, if you
Okay.
It should be.
Well, this bypass valve is different than the ones you guys have because it's just a different flow pattern, but it's the same idea. So here's the bypass valve. And what this bypass valve is representing right here is that the pump is not running at all, is the easiest way to look at it. So you have the boost pump coming and it gets to here. It can't go past these vanes. That's blocked. That's one of the drawbacks of a constant displacement pump. So it's got to have another way through. So it finds this, comes up through here. These little holes right here are drilled in there and it pushes down this plate and fuel flows through. When will this plate close?
When the pressure of the pump inlet is weaker than that spring.
Well said. When the pressure here from this pump, from the engine-driven pump, exceeds the boost pump, then it will close. Because what if the inlet pump pressure was, let's say this is 50 psi coming in, and I'm barely turning this right here. And so this is only 10 psi. Then what's going to happen is this pressure here is not enough to build up and push this up. So everything from the boost pump is going to come up through here and in and mix with this. And then when this pump gets to 50 psi, then 50.5, then this pressure here is greater than the pressure here, and so it pushes it up. Well, I should say, honestly, the pressure here plus the spring is greater than this, then it will push it up. Now, how does that come into play with this? Your pump you're going to look at is different. They're very independent of each other. So in reality, the pressure regulator, it has a hard time coming around and through. So trying to think how your pump would work. I don't think your pump would actually regulate at all the boost pump. No. But anyway, that's how the bypass valve works, right? And so when the boost pump pressure is greater than the pressure here from this pump, then it will be open until this pressure exceeds that pressure. Then it pushes it up, and now this pump does all the work. Got it? Mm-hmm. All right. Any questions about pumps?
So relief valve will not work, right?
Well, yours is different. So it will still work going this way, but it won't work going this way. And we can even just look at it and go, well, as long as this 50 is greater than this, can't push it up because that 50 is going to be pushing here and pushing here. So that's going to create a problem. And honestly, the pump you guys are working with is the same way. It's got a very large surface area. So as long as the boost pump is exceeding the engine-driven pump, it's going to stay down. It just has to. So when you're working with the pumps, just take your time and think things through. All right. Just make sure that you're not just spewing out.
So this question, if it's after main pump, if there will be two small orifices, so main pump will be increase the pressure and boost pump will be increase the pressure.
Okay, so you're saying if I have a very small orifice right here, will the pressure of this start going up?
Yep, and this pump also will pressure will
Nope.
goes up. No?
Because this right here is going to open up.
Ah, okay.
And under most circumstances, this pump here is usually more powerful than the boost pump because the boost pump is centrifugal, or not constant displacement, at least. Okay, we're good. Discard. Back to fuel injection systems. All right, we're talking about the RSA fuel injection system. And when we left off, we were talking about the fuel nozzles. Fuel nozzles are a fixed orifice. And the more pressure I try to put through a fixed orifice, as the PSI goes up, what happens to the flow? The flow increases. All right, I guess that was a good use of our time then. So the RSA fuel injection system, as I give it more throttle, I'm going to get more air metering force. And the air metering force is going to want to open the servo valve, or poppet valve if you want to call it, which is going to open that up, which is going to allow more fuel pressure, thus, and flow to go through the poppet or servo needle out to what comes next? Flow divider, where it has what inside of it? A V slot, and that is going to be doing the regulating before we get to full throttle. But once we get to wide open, the V slot opens all the way up. It's no longer any sort of restriction. In the flow divider, the next restriction is the injector nozzles, where they're designed to operate at wide open throttle. And so the higher the pressure goes, the more flow we're going to get through the injector nozzles. And that's the way it's supposed to work. All right, so we were talking about, let's see, flow through the total total flow is unchanged. And that brings me to a point number 3, which is on turbo engines, turbocharged engines. This configuration, and that's the normal configuration. As I showed you the picture yesterday, close this one down. The picture yesterday of the standard nozzles, we had a low pressure here and a higher pressure here, and so it was allowing ambient air to get sucked into the nozzle and through, right? Okay, so this configuration would result in what? Anybody remember?
Air going the other way.
Yeah, fuel going the other way. Okay.
Blow it out into the engine compartment.
Fuel being blown out of the bleed hole. So then what do you got to do? Well, you got to plumb it overboard, right? No, that wouldn't work.
Just plug it.
Just plug it. All right. Turbo engines. Use a shroud around the nozzle. That is pressurized. With what? Anybody remember?
Upper deck pressure.
Upper deck. Why can't they use manifold?
Because it's divided into...
What's the difference between upper deck and manifold?
Upper deck is straight out of the whatever compression system you're using.
Okay,
now.
turbocharger outlet up to
The plenum.
the throttle valve. Throttle valve to cylinder is manifold. So why am I specifying upper deck pressure, making a big deal of it, instead of saying, well, as long as it's higher pressure air than ambient, why not just use manifold?
Is the Venturi right there by the throttle plate as a metering device?
The cylinder
or
can fluctuate.
item?
Well, it's actually quite simple. Where's the nozzle going into?
Intake.
Cylinder.
Into the manifold. So if the manifold pressure on this side is equal to manifold pressure on the outside, what happens to the air bleed?
It doesn't work.
Doesn't work, doesn't go anywhere. So it's got to have a higher pressure on the outside than on the inside. So since the inside's already going to manifold pressure, we must have the outside higher pressure. And what's the one place on a turbocharged engine where we're going to get higher pressure than the manifold?
Upper deck.
Upper deck. You need a pen?
I have my tablet.
Oh, okay. Use a shroud around the nozzle that is pressurized with upper deck. Which is turbo output. Hey, I gotta move my screen here. Everybody good? All right. Point number 4. On the light combing or RSA systems, there is an A stamped on it, stamped on one flat, on wrench flat. Everybody know what the wrench flat is? Okay. This is a wrench flat right there. The flat spot, flat spot, flat spot, flat spot, flat. That's the wrench flat. Okay? Right there, right there, right there. So there's a little A stamped on. Right there. There's a little A stamp, but there's only one A. And an A is a big deal. So the A stamped on wrench flat indicates 180 degrees from air bleed hole. Which is to say the air bleed hole is on the opposite side of the A. So air bleed hole in nozzle body. Now let's think about if I have an injector and I install the injector in a horizontal position, where would I want my air bleed? This way or this way or that way or coming from the bottom?
I'd say from the bottom.
Top to bottom?
I'd say bottom to top.
I'd say top to bottom.
I would think that something could fall into it and plug it.
It's got a nice screen around it. It's hidden, but if we put it on the bottom, we could get fuel leaking out more.
Oh,
Okay, so one on the top. So why they do it this way, I don't know. Wouldn't it have been nice to say the A shows you where the hole is? But no, the A has to be 180 degrees out from the hole. So first thing I remember, okay, it's not the hole. It's 180 degrees out, so it's on the bottom. Thank you very much for that. And so if I put it in horizontal, where should the A be? Visible or hidden?
Hidden.
Hidden, so you always got to hide your A-hole. Everybody will get that right on the test, I trust you. So install A toward, you can fill it in if you want. There's always room on the Scantron somewhere.
As long as you hide it.
Toward the bottom so that the air bleed is up. Well, there really isn't any A-hole in the... It's right there. I found it. All right. This is kind of way out. Flow test. One of the things that you actually have to do quite often as a mechanic is do a flow test. So whenever somebody is having problems with their engine, it's rough idle, and you've already properly set the idle mix and the idle speed. They have mixed matched CHTs or EGTs or any sort of problem. One of the simplest tests to do is a flow test. And the flow test is, they say to use baby bottles, but I don't recommend baby bottles because I have, as you know, 6 children, and once you use their baby bottles for fuel, they don't like drinking out of them anymore.
Why? That's good for them.
And my wife gets mad because, do you take my good baby bottles again for another flow test? Maybe.
How
Why?
to do that, honey?
So, so you'll see most mechanics in general aviation have 6 little cups that are all about the same size. And yeah, they say baby bottles. Plastic doesn't work as well with fuel as you think. But anyway, so all you do is take out all the fuel nozzles from all the cylinders. And they're connected. You can see they're already connected here to the little lines. And you just going to flow some fuel in it. All right, super mechanics. How am I going to get fuel to come out of those nozzles?
Turn on the boost pump,
Turn on the boost pump.
full rich,
Full rich.
and let it run.
And let her run. It's just that simple. You can add some throttle.
Wouldn't do much
Why not?
because mixture is the only thing that you really need turned on.
Well, it wouldn't do much because why though?
Because your engine-driven fuel pump is not running.
Nope.
You have no air metering for it.
Have no air metering force. Hey, somebody's paying attention. So I'm running off of what?
Idle spring.
Idle spring. Unless you hook up some little straw and you blow into impact tubes. But I don't recommend that.
That will not work in the Continental.
But then you wouldn't have any the
Yeah.
Venturi air coming through.
Okay, so Juan's asking what work in the Continental. Well, we haven't talked about the Continental. It's a completely different system, but yeah, you can still get fuel to flow just through 'em. So what am I going to be testing with this? Am I testing the integrity of the servo unit? Not to too much. It's if the servo valve is open on the spring, that's all you're really going to amount to. You can look for other things. Fuel running out of the impact tubes, which will tell you what. Yeah, you got some leaky seals or diaphragms going there. But what you're looking at that, and if you have one of them that's a little different, let's say this one right here didn't have quite as much, then what does that mean?
Then that means the jet is plugged.
Jet's just plugged, and that happens. Or it could be a kinked line. All right, so I have a real heartache. Is that the word I want to use? About building hoses in the field. And I tend to soapbox. I tend to stand alone on this one, but my first experience with that was I believe it was a Cherokee 6. Is that a 6-cylinder Continental? Okay, that'd be 6-cylinder. Yeah, so Cherokee, and I got a call for a guy who made an emergency landing out at Franklin Airport, and he bought an airplane that had been sitting for a very long time, and some mechanics. There's a lot of hoses on fuel injection, right? So mechanics had built new hoses for him in the shop. And you guys are going to learn how to do it. It's part of being an A&P. It's part of the test. You have to know how to do it. And it's a good skill to learn, I suppose. But the mechanics built all new hoses, and those hoses took him all the way almost to the crash site. What had happened is when you build hoses, when you do it, you'll see, but you have a rubber hose, and these metal parts go in and they're very sharp. And as they go in, they have a tendency to, like a razor blade, skim off some of the rubber. And I talked to a guy who made hoses for a living, and he said in their hose shop, they'd actually seen a time or two where somebody had got a little bit crooked and filed off enough of one part that it made a flap. And what does a flap do in a hose? Check valve. Made a nice little rubber check valve out of it. Anyways, this Cherokee 6, it almost went down. Guy barely made it to Franklin, was losing power and just had enough to get to Franklin. So we go there to troubleshoot the engine and took off the flow divider, and it's packed full of rubber. Just all this rubber shaving. There's a screen in there, just packed full of it. And so, we cleaned it all out and said, what we need to do is disassemble all of this, flush the whole system, get it, do all of this. And he was on his way to somewhere, and he refused that service. We put it back together and ran it on the ground and made perfect power. And he said, okay, that is the problem. We verified it, proof of concept, and now we need to get some new hoses made and take care of this problem, flush everything. And he said, no, thank you. I'm out of here. And almost had his second crash immediately after that. So took off, and I can't remember if he flew to my shop at Clarksburg or made it to executive, because it's been a long time. At that point, he took our advice because it plugged up again in that short a time.
So what was wrong? Was that what happened? Was they got the fitting on crooked and it made the flap?
Oh no, a bunch of debris, all the hose debris. So if you talk to somebody, and so Sacramento Sky Ranch are no longer around. They used to make all the hoses for us. So I'd go in and get a nice, this is how it's done in a shop. I'm like, wow. When they build hoses, it's a lot different than it's done in the field. First of all, they build the hose, nicer equipment, and then they sight through it. They use brushes like gun cleaning brushes, go through it a bunch of times. Then they put it in a case that has safety on it, and they pressurize it to it at 1.5 times its burst pressure. And so there's and then they flow test it both ways, and so it's a lot different. Anyway, that's my soapbox and why you'll never see me making a hose. If you want to make a hose, you can make a hose. I'm okay with that. But, all right, so flow test, let's see. Use cups, let's just use cups. Equal size. Let's see. Flow should be equal.
Wait, so why would you use baby bottles?
It's what RSA in their film. They say baby bottles because baby bottles have the little graduations on there that tell you exactly,
A beaker would work.
You have 6 of them.
Yeah.
Or 4. Also red Solo cup. Or I don't care. Never clean. Never clean. This is hard. This is a hard one to do. Never clean the nozzles with wire. Because where are you going to get wire as an aircraft mechanic? Why, every mechanic I know has 3 choices of wire on their toolbox, with wire or drills, unless you want to buy new ones. How many people are familiar with ultrasonic cleaners? How many people are familiar with ultrasonic cleaners, where you put something in ultrasonic cleaner and a couple minutes or hours later you pull it and go, wow, that really worked?
A little bit. We used to use it for instrument repair for musical instruments.
For what?
For musical instruments.
Okay. And it actually worked?
It's fantastic.
Because every time I've ever experienced it, I thought, somebody sold a bill of goods or it's not really working. I don't trust those things. Okay. So some people say, oh, you should always clean them in ultrasonic cleaners. I don't know. Recommended cleaner as far as I'm concerned, and according to service instruction 1275 Charlie, that sounds like a Lycoming recommendation right there, is how do you pronounce that?
Hops.
Hops. I say hoppies. That's why I asked you. Yep. Where do you buy hoppies number 9? Walmart sells it.
So what is that?
It's gun cleaning solvent.
It's like the best smell ever.
It's definitely.
I love that smell.
It's, you know what? That's how you just. How many people? Raise your hand if you have a bottle of hoppies at home. All right, there's your gun people right there.
What's it do?
So it's just so for 20 minutes, rinse with Stoddard solvent. Hoppies number 9 for 20 minutes. What is Stoddard solvent? Stoddard solvent is exactly what you guys have been dealing with on the carburetor bench. Salt water. Tim thought it was salt water. That's okay. All right, now you get to do my favorite thing. Blow dry with shop air. So you're actually allowed to use shop air now.
Right.
All right, so here's where things start all going to heck in a handcart, right? As mechanics, right? So we know we got a problem, so we're going to get it out. We're going to do the flow test. Everybody's fine there. Flow should be equal. It's not. So mechanic picks up some wire and shoves it through there. I can see it from here. shoves some wire through there and scratches it all up, changes the orifice size, so now it's not working so well.
You have too much flow.
Yeah, doesn't have any hoppies number 9, so that works out. Anyway, you think you did it, so you're going to put it back in. So these are a pipe thread. So pipe thread is sealed in what manner? What makes the seal on pipe thread?
Cuts into it.
It's a conical shape. So the tighter you make it, the more it wedges itself in there, and the tighter the seal. Well, you don't want a fuel leak, right? So smash it good. Ah, if a little tight's good, a lot's better. All right, do not over torque. Do not over torque. They're very sensitive little things, and they break.
So would it just snap if you over-torque it?
I don't think I've ever. Well, I never had one snap, but I've never also over torqued one. I've had the luxury of breaking them as I pulled them out. So yes. I don't remember. The torque is not much at all. It's very, very low. It's like 40 inch-pounds or something like that. Okay. Then, so most people are pretty good about that. But then they go to put the injector lines on top, and that's where they really go crazy with the torque. And nobody wants to torque it. So it's easy to torque the nozzles in because, 7/16 or half inch? It goes right over deep socket, just fine. Torque it, no problem. Now you got to put the lines on, and it's got a line in the middle. Well, how are you going to get a wrench on that? Well, now you got to get a crow's foot. Nobody wants to do that, and so, just a little tight. But hey, here's the good news. All right, so watch. Well, I get that. So watch for primer lines used as injector lines. They look very similar, but they're different sizes. So, and primer lines are what you guys are familiar with on the ground power unit. You pull the primer and push it in. It's the line that actually runs around. That's a primer line. Injector lines are stainless steel, and they're just a little bit different size, a little bigger. Nope, or smaller. They're different. I think the inside diameter is smaller. And then, let's see, primer lines. And
What do you mean by watch for the primer lines?
inspect for.
Oh.
Inspect that somebody put the wrong line on. If you have 3 lines that look like one and one that's different, question it. People do crazy things. Torque the injector lines. You have to. You have to be careful. So the torque is 20 to 25 inch-pounds. That's not very much, is it? Or, because remember how I said, how are you going to get a torque wrench with a crow's foot and all that? It's not going to work. Or, let's put this, or finger tight. This is for real. Finger tight plus 1/2 of a flat. So it should go finger tight all the way down. And of course, if you've got boogers on the threads and stuff, and you can't finger tight it, okay, that doesn't count, right? Now you have a different problem. But you should be able to screw it all the way down until it seats, and then you take the wrench and you go 1/2 of a flat. So if you have, your hexagon, just beep, a little bit. So, and that's it. That's the proper torque.
Who says you can do that?
I'm glad you asked. Service Bolton 342 Golf. No, wait, that's something else. I actually pulled it up in a Lycoming service instruction and an RSA bulletin. So it is actually not just some, what's the word? The norm. It's a legitimate instruction. There we go. Inspect. Inspect injector lines. Every 100 hours / annual. And guess what? That is AD 2015-19-07. And it's actually a pretty old AD. So 2015, that's the year this AD came out. But this AD came out a long time ago. It's just revised so much that That's called 2015. So if you see an AD that's something like 63-01-12, this is the year that it came out. So it'd be 1963. This is the biweekly. So it was the first biweekly that came out, and that was the 12th one of the series. So this came out in 2015 at the 19th biweekly. So now you know when they come out. Let me just finish up a few little things here, and then we can. Yeah.
For that AD, when you say every 100 hours or annual,
Yep.
would you have to do it every 100 hours even if the 100 hour isn't required?
If the AD says you must do it every 100 hours, then you must do it every 100 hours of operation. But you're thinking of 100-hour inspection. What if I don't have to do 100-hour inspections? AD still says you must do it every 100 hours. It doesn't say every 100-hour inspection. It says you must do it every 100 hours. Now, if it said every 100-hour inspection and you weren't doing it, I don't know if they word them that way. It would be every 100 hours or annual, whichever comes first, and or I have to read it, but newer style.
You're inspecting the injectors of the lines.
The lines. There's very specific. There's an AD that has very specific requirements about where the clamps go, how often they're clamped, the part numbers of the clamps. You can't mess with that, because what happens is the fuel injector lines are subject to vibration, and they'll break. So, fun fact, and then I'll let you go to break. I just finished reading a book about the making of the Boeing 777. It's a fantastic book about what it takes to build an aircraft. And this was Boeing's first attempt to build an all-digital aircraft. Before that, they would build everything on paper. Then they would build wood mock-ups, and then they would build another airplane. And as they got to the airplane, they'd realize how many things intersected and bumped into each other. They'd have to go back and do all these engineering changes. But with the 777, they decided pretty much the first aircraft that rolled out of the assembly line should be put together properly, without problems, roll out the door and fly. And it did. And so they did this all on paper. But anyway, the thing that was interesting to me is as they were developing the engines for the airplane, one of the things that was Pratt & Whitney and Rolls-Royce, the engine manufacturers actually take the engines and they put them on shakers, and they do these shakes at different vibration frequencies and find out what breaks and then add clamps. So it was just kind of a light bulb to me that, wow, these clamps, where they are put, is really important. And so tie that in with 2-3 years ago, Lodi Airport, there's a Cessna Caravan with the Lotus skydivers that took off, and it crashed right after takeoff. And so it nobody got hurt, and that was a nice thing. It landed in a vineyard, and it flipped upside down, so it killed some grapes. But what had happened is they replaced a fuel line that had broke 2 hours earlier, something like 2 hours. It was a very, very low time. And so fuel line broke, so they replaced it. Breaks again. Why did it break? NTSB showed the pictures. None of the clamps were replaced. You just stuck the fuel line back on. Those clamps, where they are, how they went, was critical to keeping this thing in the air. But to them, it was just, the mechanic was just like, clamp, whatever. So we see that in general aviation, especially on the Lycoming fuel injection. So, all right, break time.
At least they weren't expecting to land anyway.
Yeah.